Thank you. So we'll go to the next talk now from Christophe Massion about multicast using the Upipe framework. So you have been here many times, I think, but here you have a really practical application of Upipe. So please, Christophe.
Thank you, Matthias. Yes, so the talk will be about a new protocol that's called Automatic Multicast Tunneling, or AMT for short, and the proof of concept that we've done with a web browser and Upipe to display multicast content inside the web browser. So I start with a little introduction about multicast. So why do you want to do multicast? Because it saves network bandwidth by avoiding packet duplication. And of course it is particularly useful for television, but not only. How does it work? Well, in a unicast environment, for each client, the server has to output the data once. So there is duplication here 3 times, here 2 times of the data in the backbone. In multicast, well, the client who wants to receive the data asks the local router to send him the data. If the router doesn't have the data, it asks to the upstream router, and so on. And if the router already has the data, it just duplicates in the correct way, but it doesn't duplicate all the way to the server. So it's much more bandwidth efficient. And for big streams like IPTV, it's of course very useful. So the first specification about multicast was called any source multicast. It's an RFC. So basically, multicast stream is defined by an address. So to subscribe to a multicast stream, you just give the address, and there are several subscription protocols that are very complex that allow the multicast stream to be sent from the server to the client. So this also requires a central authority to assign multicast addresses, because there are a limited number of it, and this is currently mostly used, or probably only used, in closed IPTV networks. There is a second specification a few years later that's called source-specific multicast. So in this specification, a multicast stream is defined by its address, multicast address, and the source that sends it. So 2 addresses. So that makes the subscription protocol much simpler, because if you want to, when you want to subscribe to a stream, you just go upstream towards the source. Maybe it will stop somewhere because a router already has the stream, but the scheme of subscribing is much easier. So it's also very common in IPTV network, in closed IPTV networks. As you can understand, it's also been built for the internet. But have you ever already seen a multicast stream on the internet? Probably not. So why? So first reason, because there was no incremental adoption strategy. That is, either you're on a multicast network and you get the stream, or you're not in a multicast network and you get nothing. So it's 1 or 0, and since today it's mostly 0, no one has an incentive to do multicast. Also the industry, people in the industry like Cisco, Juniper, Alcatel and so on, well, they concentrate in delivering IP multicast in networks that could support it already. So they're not interested in the big internet so far. So far, because a few players have gathered to create a new RFC. So currently it's only a draft. That's called Automatic Multicast Tunneling, AMT. And it's a protocol between a gateway that would be on the client side, close to the client or in the client, and a relay that would be server side, close to the server or in the server, or close. And so this protocol allows multicast distribution to extend even on unicast-only connected receivers. And in other areas, well, if you are already on the multicast network, you don't need AMT, so you have the benefits of multicast. And for the applications, you don't have to change a thing. It works seamlessly as well. So I detail a bit how it works with this slide. So if the streamer is on the right, content owner, so if you are in a multicast network like the one on the bottom, you have the purple video streams that are flowing in just one copy down to the clients that are down there. So everything is perfect. Now, suppose you're in a unicast-only network like the one in the left. Well, the clients here well, they want to subscribe to a multicast address, but nothing comes because the network doesn't have the notion of multicast. So what do? They ask to talk to the nearest relay, so they discover the nearest AMT relay with an anycast address. So the anycast address will point to this relay here, pointed to by the big black arrow here. And this relay here will send a copy of the stream to each of the unicast clients. So instead of sending from the server to the client, it's only from the nearest relay, available relay from the client. So it has another interesting side effect in that, well, the ISP here, well, probably we want to switch to multicast as soon as possible, or partly to multicast, because that would make his backbone, well, more efficient than it used before. So the way it works AMT is that first the client does a standard multicast join, IGMP. It waits for some kind of a timeout. IGMP is not a two-way protocol, so you don't have an answer, but you must wait for a timeout like 2 or 3 seconds or 5 seconds, something like that. If you don't get any stream, then you switch to AMT protocol. So AMT, anycast address, you get the address of the nearest relay. You say, I want to subscribe to this group and this source. And the AMT relay will set up a point-to-point unicast tunnel with the wanted data. And when you want to unsubscribe, well, same way, you ask your relay to unsubscribe you. So AMT looks great. There are also a few things that it doesn't fix. So AMT is a UDP protocol only, just like most of the multicast streams as well. So if you have packet loss on your network, well, you have packet loss at the end. So, AMT doesn't fix that. Also, if you have latency, jitter, packet reordering, well, you have to deal with that at the application level with protocols such as RTP, for instance. Also, if you have network congestion, you will not be able to do adaptive bitrate streaming like you do currently. You have to implement that at the application layer as well. Switch to a different multicast stream that would be lower bitrate, for instance, that kind of thing. But this is application. So now I turn to the proof of concept that we've tried to do to demonstrate the technology. So it's a proof of concept that we've done with the EBU, that is hosting the servers that we use. Also, Cisco has provided a router, and OpenIDN, my company, has also provided a streamer and some code. And so the proof of concept was to be able to display a multicast stream in a web browser using AMT, switching to AMT if needed, without having the AMT support in the OS or in the network, because that would be cheating. So the first question that you ask probably is how you display such kind of video in a web browser. Well, nowadays you have things, great things like HTML5, Flash and so on, but it doesn't deal with UDP. It deals with files, it deals with HLS, chunk delivery, and so on. So if you want to do a non-standard protocol, how would you do? Well, 10 years ago, you would have done NP-API. So NP-API was the way to do Mozilla plugin in a web browser, not only for Mozilla browsers, by the way. Lots of browsers supported it. It's now deprecated and even disabled on some browsers nowadays because it's not secure. From the same era, you also have ActiveX, but that would be Windows only and Internet Explorer only with the same qualities and faults. Promising technology, media source extensions, MSC. I've looked into it, but it looks very tied to chunk delivery. Some chunk delivery like HLS or Dash. And it doesn't, I don't think I could have done something with it with packet-based delivery like we have. So we've turned to a technology called PP-API and native client. So that's a technology by Google. And it allows you to run native code, so native C code inside a web browser, actually inside a sandbox. So that protects the environment of the user from, well, malware and so on. So that's an interesting technology. So for the web browser, we have PP-API. The other components we've used is, well, Cisco's open source AMT libraries. So I think it's BSD. You can download it on GitHub. The slides are available on FOSDEM side, FOSDEM websites if you want. So the AMT libraries is written this way. It mimics the standard socket, BSD socket API. So you have a call to open a socket, you have a call to join a multicast group, and you have a call to read from the multicast stream you want to read. And the library will either do some SSM, standard multicast, or AMT after a timeout. So the library does the work for you. So all you have to do is use the library instead of joining the groups yourself. And we also needed a multimedia framework to bind all of these together. My pet project is Upipe. Kieran talked about it earlier today. So Upipe is a multimedia framework that is lower level than VLC and GStreamer. And it allows you to connect pipes next to each other. So here you have one pipe that is the AMT source that does the job of getting the packets, a TSD mux, decoders and scaler and resamplers are from FFmpeg. And we already have a display module for native client in Upipe, so that was used as well. So the current POC works. I'll show a demo later. There are also a few limits that can be quite annoying. The first limit is that sockets are blocked by default in native clients. So that's a bit of a pity. You cannot open a socket at all. There is a Chrome flag to enable some kind of socket support, but not enough for our case. For our case to work, you have to specify a command line switch to Chrome. So that's not very practical. Another problem is that the socket API in Chrome, that's all because of the sandbox. The sandbox abstracts a lot of calls, and also it doesn't have support for IGMP at the moment. There is a ticket opened in Chrome's ticketing website, but there is currently no IGMP support. So actually AMT is the only thing that works in the plugin. So it's interesting to see how AMT can be a workaround for that kind of situation, actually. Another caveat is that while there is no assembly optimization, no MMX, no ICC, and so on in FFmpeg, so that makes the decoding very slow. So it works with SD video. With HD, you'd better have a very big machine, and probably it won't work. Native client does support some kind of assembly, MMX and SSC, but not in the way FFmpeg uses it. There is probably some kind of rewriting of code to make it work. But there is a better option actually, is that PPAPI now for a few months has featured a video decoder interface. I have not been able to have it work, so I guess it's still under development. But I think that's the way to go in the future if we want to go further that way. But probably in the very long end, AMT should probably be integrated into something native into the web browser like MSC or some other W3C specification. So I switched to the demonstration. So to explain what I'll be running here. So we have at the EBU in Switzerland, we have a streamer that sends a multicast stream to a multicast-enabled network. That's the internal multicast network of the EBU. And there is a Cisco relay that acts as an AMT relay. And here I have my PC that will talk to the relay, ask for the multicast address that's coming outside of this server, and display it. So it worked 1 hour ago, so probably it won't work today. So this is nothing for the moment. This is something. Yep. So this is a page that is actually running from the upipe.org website. So you can go to upipe.org and it's public. If 20 people, of course, go to the same page at once, probably your bandwidth won't be happy with that. I think it's rate limited to like 3 or 4 clients, Thomas told me. And so if I click AMT, here I see the video appearing. So that's streaming live from the EBU. I'm actually amazed it works so well because I'm only connected with Wi-Fi. So that means we have no packet loss from the EBU to here, including the Wi-Fi, because we would see them. There is.
It will be apparent.
Yeah. There's no except that there is RTP. That's all for packet reloading, but there is nothing else for to recover some packet losses. So.
Is there a specific version of Chrome that you have to use?
PPA API has been available for quite a long time now. We've started working with it from version 35. I think now we're at 39 or 38. So this is the latest version, but it should work with earlier versions as well. Now the only specific thing you have to do is you have to open -- allow initial socket API upipe equals upipe.org to allow this website to use the initial socket API. It's not a technical limitation, of course, because the Chrome does know how to open a socket. It's more political limitation. So maybe if we talk to Google people or Chromium people, that could be arranged. So to finish up, I'm almost done actually. So to finish up, there is also an EBU effort on multicast. So that's the URL of the ebu.ch website for multicast. There is a configuration for Cisco equipments. I should put some text about the demo as well that I've still not written, but at some point there will be. I think you need to open an account, but I think it's free, if I'm correct.
You need an account on tech.ebu.ch, but then you can normally access the workspace. It's a wiki, basically.
Yes, it's a wiki, so you can modify it as well. So that was the end of the talk. If you want to, well, we still have some time for questions. If there are questions that are left unanswered, you have my email here, and there was also a meetup from the Upipe team tomorrow, Sunday at 2 o'clock. So at the Both room, I think there is only one Both room this year. So upstairs. Anyway, you know where it is.
Okay, thank you, Christoph.
Thank you.
Are there any questions? Yeah, lots of questions. So yes, please.
What are the perspectives of what is planned to go further without the need for the PPA API plugin and native code and so on? What are the next steps for adoption?
Well, what are the next steps for adoption of the AMT? So probably, well, this is just a proof of concept that we've done. It probably wouldn't be the way to go in production. I think if people wanted to, well, that's of course very interesting for broadcasters because that would save them a lot of money on CDNs and so on. So broadcasters would be the primary client of this technology. And most of the time, broadcasters have an application that allows applications on iPhone or Android applications and so on, or on the TV, connected TV. So probably they will need to merge this code to the libamt directly inside their application. So that would probably be the next step for them. If we want to do it as well in the browser, the best would be to merge it into some kind of MSC.
Is there any work going on to specify this?
Not that I know of. The AMT is still not specified today. It's still a draft. So that means the specification may still change. It's version 18, so it's an advanced draft, but I think it will become official very soon. I think the expiration of the draft is June. So, but it's still a draft. So for the moment, it's quite new. It's something that's been done last year only. So.
Also, I remember that a few years ago there was a free implementation of the relay. Is it still maintained? I have a Juniper network and actual multicast transit. So I would like to run a relay, but I need some code and not a Cisco implementation.
So the question is if there is a free implementation of the relay.
There was one. Is it still implemented?
There was. I don't know. I haven't seen this code. libamt, from what I've seen, is only the implementation for the client. Do you know who wrote the free implementation for the relay?
I can't remember. It was somebody from ISC, I believe.
Okay,
the time.
somebody from ISC, but I don't know this. So sorry. I know Cisco and Juniper have implemented it into the product, some versions of the product. Sorry, probably the experimental firmwares as well. But about well, an open source relay, I don't know. The protocol is actually quite simple, so it wouldn't be difficult, I think, to write.
Other questions? There were other questions here just behind. Yeah.
In practical means, is there a way to enable some kind of delay or time difference between two end-user endpoints? I mean, is there a cache in the router that needs to enable such a thing, and what's the practical time difference between two endpoints?
So the question is there a way to add a delay between the well?
So basically, if everyone needs to see the same stream exactly at the same moment, or
Okay, so it's about synchronizing several clients so that they show the same picture exactly at the same moment. So that's your question.
yeah, I mean, how live does it need to be, or can it support some kind of not real-time live?
Like a delayed real-time sort of thing.
If it would be able to support VOD, well, multicast is designed to send live data. However, there are people who are doing video on demand also as well on broadcast technology, even on the DTT and so on. So basically, that works with pushing the content earlier. So, for instance, if you know that one of the of your content will be viewed a lot, you can push it a few hours earlier or during the night when there is not so much bandwidth used in the DTT or the satellite or your IP network, and so the client can cache this data and read from the hard drive when you read it. So that's it's something that standard practice already in the broadcast industry, in the DTT satellite world. So the same kind of behavior could be implemented with IP and multicast, of course. So that would require the client to always subscribe to a multicast address that would contain, a carousel of files that would be often watched. You could maybe do it as well for some kind of replay TV or so on, but that would require your customers to have pretty much to view the show pretty much at the same time. That's not impossible, but that's application defined, I think. That's higher level.
Okay. Yeah, I think there was who was first? Don't remember. Yeah, but maybe go.
Just one question regarding most of the customers will use Wi-Fi. Now, I mean, nowadays we have, let's say, 90 or 99% of people receiving data from Wi-Fi. Native multicast streams are not very suitable for default Wi-Fi because they are sent at a fixed bit rate, which is going to kill more or less the rest of the traffic. How do you plan to deal with this?
Well, short answer is that we don't. Well, I had a slide saying very clearly that what we don't deal with. That's kind of the things we don't plan to deal with. It's probably an upper layer of protocol.
Which means the Wi-Fi router will have to do the multicast-unicast conversion itself anyway.
Yes, probably.
Okay. You had a question?
How does AMT handle NAT traversal? Because if you send UDP, you need to...
It's unicast UDP, so you will have to you would have to have a module in the NAT as well, because from what I remember, the protocol first works by sending a packet to the relay, and then the relay gives you the address of the machine you have to talk to get the stream. So there is another circuit to open. Since you're the one initiating the connection, probably it would work if.
Yeah, but you need to have your address. If you're inside the NAT, you have a private address.
Yeah, but most NATs I've seen, when you send a UDP packet to a destination and the destination replies, it works.
Yeah, it's usually accepted.
Usually it
Everyone
works.
Initiating.
Yeah,
Yes.
and we are initiating in this case, so it should work, I think. Yeah. Good answer. DNS wouldn't work.
Okay, there was a question at the back first. Yeah.
As far as I understand, you did some preparation from ISPs for Upipe.mp4. Are you seeing actual interest in doing that? Are they moving or are they standing still? Are they active or?
So the question is whether the ISPs are active in this domain and are, well, proactive, I would say, in this domain. We've seen some ISPs, some network operators, I think, at the workshops that we've done at DBU already. So some of them are. The protocol is, of course, a preliminary version. To run it on the Cisco router, you have beta firmware in there. So, of course, it's not production ready. But the incentive is that if you're able to spare a few gigabits of data on your backbone, maybe it's worth doing it. But probably the main incentive will come from the content provider, because that's the people who are paying money to send streams.
Last question, yeah.
Is there a discovery mechanism in the protocol to discover the closest relay?
Yes. So is there a mechanism to discover the closest relay? That was a question. It's an Anycast address. So I'm not the biggest network specialist, but I think Anycast basically will point to the address that you're given will resolve in some way to the nearest relay. That's the principle of Anycast. A-N-Y, Anycast. Do you want to explain more how it works?
No.
No. Nico? No? C'est bon, j'ai...
Maybe you can discuss afterwards. So,
Yeah.
We'll conclude here because we have to go to the next talk. So thank you very much, Christophe.
You're welcome.